In this video, we'll take a look at models of the atom. Now we'll look at Bohr's model and the quantum mechanical model. So in the development of atomic atoms, we've got to the point where we have Rutherford discovering the nucleus of the atom, and then he took the idea of his nucleus and then other previously thought about ideas of electrons, and he made this model of the small nuclear center with all the mass and each electron having its own orbital path as it revolves around the nucleus, just like that of the planets. No planet crosses paths and gets in interference with the other paths of the other planets. So his model did not explain, though, the chemical properties of these elements. Why did they always react the way they did? What gave them the properties that they had? So a student of his, Niels Bohr, is a Danish scientist who had been working under him and then kind of continued his idea of this atomic theory. He continued studying atoms, looking at how these electrons would be found in these specific orbital paths around the nucleus. Except he changed his idea by looking at the energy they had and the fact that these electrons had the ability to move out of these orbital paths. They had these energy levels, and if they gained and lost energy, they could bounce between these different energy levels. Unfortunately, his model only worked for hydrogen because these negatively charged electrons would repel each other when they're in this small space together, and it didn't quite work properly with the other elements. So again, that energy that he came up with and the idea of how that would relate to these electrons, when he drew his model, electrons with lower amounts of energy were closer to the nucleus. But again, they weren't in a fixed path like that of Rutherford. They had the ability to bounce between these different levels if they were able to gain the right amount of energy, known as a quantum. If it was absorbed, they can move up to a higher level, and then if they lost the energy, they move back down. Quantum like quantity because it was a measurable amount. It was a fixed, measurable amount of energy to move between these different levels. But not every single electron needed the same amount of energy to get from, say, level 1 to level 2 as it would be from 2 to 3. And in every different element of every different atom, it's not the same amount of energy between that 1 and 2. So the energy between level 1 and level 2 for hydrogen is different than the amount of energy that would be needed for level 1 and level 2 for helium. So Rutherford's model is, again, as we see here, that small, dense nuclear center with each of those electrons traveling on its own fixed orbital path. And then here's Bohr's hydrogen atom right here. Again, that one singular proton. And right now the electron's in that second energy level. So it's gained energy. It's in what we call an excited state. And it can then lose energy, fall back to the first level, or even gain more energy and jump up to the third level. Then the next development with atoms was by Erwin Schrödinger, the quantum mechanical model, and he would look at the amount of energy that these electrons had, and based upon the energy they have, what position they would be relative to the nucleus, and he then kind of make a scatter plot and look at those probable locations of those electrons, how likely it was to find those electrons around the nucleus, and then he would make these orbitals that were based upon that likelihood, and there'd be more darkly shaded areas for the places that was more likely to find them, and more lightly shaded areas for places to be less likely to find them, then obviously nothing at all where there wouldn't be anywhere to be found. So it kind of looks like a revolving propeller blade, because in the middle, where it's more likely to see those propeller blades because they're moving more slowly, it's much darker than the outsides where it's moving really fast and less likely to be seen. So here's our revolving propeller blade again, as we discussed. Right there in the middle, see where it's really, really dark. Outside, again, moving much faster, less likely to be found, and it's a more lightly shaded area. Once you shut off your fan and those propeller blades stop moving, we know those propeller blades are the same width all the way across, but it appears that they are much thicker in the middle because it's moving more slowly in the middle and more likely to be found in the middle to make a greater percentage of the area in the middle of that circle, as opposed to the outside, again, where it's really moving fast. It's going to cover a lot more distance in the same amount of time. So then here's how Schrödinger then looked at those mathematical probabilities. Again, we see in the middle it's much more dense, much more darkly shaded because it's much more likely to find electrons there. And as you move farther away, it becomes much more spread out, much less dense. And this one actually makes the shape of a sphere, which we'll talk about in a moment. So these orbitals, again, are a most probable place to find the electron. Not exactly 100% for sure, but again, 99.9%, they're most likely to be in these places. And these orbitals live in energy levels just like Bohr proposed, those rings he had, energy level 1, 2, 3, 4, all the way up to 7. Each energy level, as you get higher and higher, is associated with more and more energy, but these atomic orbitals, again, are made up of sublevels. They're different, smaller energy levels within those larger levels that Bohr proposed. And those sublevels are S, P, D, and F. And each of those corresponds to different amounts of energy in different shapes in which they are carved out by the probability of finding those electrons and how those electrons move when they're within these orbitals. Whether it's an S, P, D, or F, each of these orbitals is able to hold 2 electrons. It could have 1, could be empty and have none, but it can't hold any more than 2. Each of these orbitals, depending on what type of atom it's in, what energy level it's in, and what sublevel it's in, has a different amount of energy associated with it. So in an S sublevel, there's only 1 orbital. In a P sublevel, there's 3 orbitals. In a D sublevel, there are 5. And in an F sublevel, there are 7. So whether it's in the first energy level or the 7th energy level, an S sublevel has just 1 orbital. The P sublevel doesn't appear till the 2nd energy level, but whether it's 2nd, 3rd, 4th, all the way again up through 7th, there are 3 P orbitals within any sublevel of a energy level. The D sublevel doesn't appear to the 3rd energy level, and there's 5 orbitals within that. And then the F sublevel doesn't appear until the 4th energy level, and then there on out till 7, and there are, again, 7 orbitals for every F sublevel. And here we see those different sublevels, those shapes that are associated with them. The S sublevel is a spherical shape. Again, it appears in the first energy level. There's only 1 of them, but there's 1 in each of those energy levels all the way up to 7. The P sublevel is dumbbell shapes. It doesn't appear till the 2nd energy level, but there are 3 of them in every energy level from 2nd up through 7th. The D sublevel we call a clover shape. It looks kind of like a 4-leaf clover, the exception of that one in the middle. And again, it appears in the 3rd energy level, and there are 5 orbitals in every D sublevel, all the way up through the 7th energy level. And then lastly, the F sublevel, there's 7 of them. They appear in the 4th energy level, and all the way out to the 7th. Again, anytime you're in an F, there's going to be 7 different orbitals within it. So it needs a way to kind of remember where they all fit in and how they all fit in while looking at the energy levels versus the number of sublevels. The energy level is equal to the number of n sublevels. So when you're in the first energy level, there's just 1 sublevel, and that sublevel is the S sublevel. In the 2nd energy level, there are 2 different sublevels, the S and the P. So therefore, there's 4 orbitals in total, because 1 S plus 3 Ps, 4 different orbitals. In the 3rd energy level, we have 3 different sublevels, the S, the P, and the D. So now we have 9 orbitals in total, because you have 1 S with 3 Ps and 5 Ds. And then lastly, 4th on out, you have 4 sublevels, S, P, D, and F now. 1 plus 3 plus 5 plus 7 gives us 16 orbitals in total, again, from the 4 different sublevels. So lastly, to figure out how many electrons there are within an energy level, I can take that energy level, square it, and then multiply it by 2. So each energy level has 2n squared electrons. So that first energy level, 2 times 1 squared is 1 times 2 is 2. There are 2 electrons in that first energy level. The 2nd energy level, I have 2 squared, which is 4 times 2, so 8 electrons in total. The 3rd energy level, 3 squared, 9 times 2. Now I have 18 electrons in total. And lastly, in energy level 4, 4 squared, 16 times 2, 32 possible electrons in that 4th energy level.